So next topic is what? Error detection. Already I told you the error control is basically classified into two types: error detection and error correction. So error detection is one type of error control technique, and as the name is error detection, it will detect the error. It will not correct the error. So it will monitor the received data and determine is there any transmission error is there. Okay, so it will neither correct the errors nor it will identify the bit position where the error has occurred. Next, error detection techniques are classified into four types. One is what? Redundancy. Then second one is Echoplex. Then exact count coding. Then redundancy checking. Again, your redundancy checking is classified into four types. One is VRC, that is vertical redundancy checking, checksum. Then third one is what? LRC, longitudinal redundancy checking. Then fourth one is CRC, cyclic redundancy checking. So first we study about redundancy error detection techniques. So as the name is redundancy, the same thing is repeated. Okay, so here the same data is sent more than one time to the receiver side. So see here, redundancy is a form of error detection technique where each data unit is sent multiple times, and usually it is sent twice. So at the receiver end, the two units are compared, and if they are same, it is assumed that no transmission errors have occurred. So see in this diagram, the sender is sending the character A, okay, and that character A is sent two times, and at the receiver side, if it is receiving the same character two times, okay, and it is matching or comparing, okay, the first character, that is A, and the second character is A, then no transmission error is there. But see in the second case, the sender is sending the character A two times or twice, but the receiver is getting first A, then it is getting B. So after comparing, it is getting that the two characters are not same. So error has occurred. Okay. Again, your redundancy error techniques are classified into two types. One is what? Your character redundancy, and second one is what? Your message redundancy. So as the name is character redundancy, so here your data unit is a single character. So if you have only one character to send and the same character, the single character is sent more than one time, then that will be called as what? Your character redundancy. So that is very common form of redundancy, and if the exact same character is not received twice in succession, a transmission error must have occurred. Suppose the sender is sending 0, okay, then again it will send the 0 two times, but at the receiver side, first it is getting 0, then it is getting 1. These are not same, so the transmission error is there. Then come to the message redundancy. Here what will happen? The data unit is the whole message or the entire message. That's why the name is what? Message. That means the same message is sent two times. So if the exact same sequence of characters is not received twice in succession, in exactly the same order, a transmission error must have occurred. So see here, the message is suppose hello. Okay, the hello is sent two times or twice, but at the receiver side, see the exact order of the characters are not same. Here A, G, L, then not L, O is received, then L. Okay, this one is also different. So you can say transmission error is there. And another type of redundancy that is used with the short messages, you can send or transmit the same message several times, not only two times or twice. You can send 5 times, 10 times, but the message should be short. Okay, so that is all about your redundancy error detection techniques. Next, the second technique is what? About Echoplex. Sometimes Echoplex is also called as the echo checking. Okay, the Echoplex is very simple technique. Just take an analogy. Whenever you produce any sound in a closed room, then you can hear an echo sound back to you. Yes or no? So in Echoplex, what happens? Whatever the message that will be transmitted from the sender side, the same message, after getting the message at the receiver side, the same message will be sent back as an echo message to the transmitter. So see here, in Echoplex, the receiving device retransmit the received data back to the transmitting device. Okay, so Echoplex requires full duplex operation. So in this example, suppose the sender is sending an high message to the receiver. After receiving that high message, the receiver will once again retransmit the same message, hi message, to the sender side, and that hi message will be treated as what? Your echo message. So as the message transmission occurs in both the directions, so it requires or needs full duplex operation. Okay, and see here, if the sender will get the same message that it has transmitted as an echo message, then you can say that no error is there. But if the sender is getting a different message that it has transmitted in its echo message, then an error has occurred. So the character that is transmitted should be sent back from the receiver as an echo message reply. So if a transmission error occurs, the wrong character will be displayed on the screen of the transmitter. Then it will be changed and sent back to the receiver. So though it is a error detection technique, but it will also correct some type of error. Now see here, here the sender is sending the hi message to the receiver, and receiver is getting the exact message or correct message. But when receiver is sending the what echo message, during the transmission, that I character is changed to J, HJ, okay, and that is received by the what? Sender. But the message is correctly received by the receiver. So sender is assuming that though no, the message is not received correctly by the receiver. Though sender will change the J character into I, and once again it will transmit what? To the receiver side. Okay, so that type of retransmission is generally unnecessary. Okay, so that is one of disadvantage of what your Echoplex technique. So let's see what are the other disadvantages. So already I've explained that disadvantage. If the same transmitted character is not sent back as an echo message, then unnecessary retransmission is there. And it depends upon the human operators to detect and correct the transmission errors. And as it is operating in a full duplex operation mode, it takes twice the time that is actually required for the successful transmission of a message. Okay, next we will go to the third error detection technique, that is exact count coding. As the name is what? Exact count. Here we are counting the exact number of zeros and ones. Okay, the number of binary ones and binary zeros in each character is the same. Suppose for example take the code 39 barcode. In code 39 barcode, each character code contains 9 bits. So among 9 bits, 3 ones are present. So to represent each and every character, whatever the code you are using, 3 number of ones should be there. So see here, in the first character code, 1, 2, 3. 3 number of ones are there. In the second case also, 3 number of ones are there. That is called exact count. If more than ones are present, then error is there, or less than 1 are present. So exact 3 number of ones should be present. Take another example, postnet barcode. In postnet barcode, each character contains 5 number of bits, and each character code should contain 2 ones. See here, 2 number of ones are there, 2 number of ones are there. If more or less number of ones is there, then error is there. Okay, if exactly 2 number of ones are there, then no error is there. Another exact count encoding technique is what? Your ARQ code. ARQ code is character code contains 7 number of bits. Among 7 bits, 3 bits are logic 1 and 4 bits are logic 0. And see here the example, 3 number of ones are there and 4 number of zeros are there. 1, 2, 3, 3 number of ones are there and 4 number of zeros are there. So simply counting the number of ones or zeros received in each character determine whether a transmission error has occurred or not. So as here 3 number of ones are there and 4 number of zeros are there, sometimes ARQ code is called as the 3 of 7 code. That means total 7 bits are there, out of 3 are ones, logic ones. Okay, thank you.